Hi there, and welcome to this new video. In this video, I want to talk about plain text. Now, many of you ask me, like one of the questions that I get asked the most is, hey, what kind of operating system are you using? What kind of tools are you using? And the answer to that, most of the time, is they are referring to Emacs. Emacs is the software I use to deal with text. Anytime I have something that is textual based, I use Emacs. It's not the only software I use a lot of other software as well. I use the browser, the video editor, just to watch videos, the MP4 player, like I use a lot of software. However, the software that I use when it comes to text editing and in general when it comes to editing textual information is Emacs. Now, growing up, learning about computer science, using computer science at work, in cybersecurity as a security consultant, and so on and so forth, has led me to realize that there is a lot of power on using plain text correctly. So, first of all, I want to mention what is plain text? What are we talking about? So, plain text refers to files that contain simple human readable text. So we can have simple ASCII characters. We can also have general Unicode characters. For example, if your language has accents, like, I'm Italian, you can hear it from the accent. I'm Italian, and in Italy we have a bunch of accents, right? So basically the idea is that wait a second, where is the I? Like this. I can use also this kind of Unicode characters to represent all the different accents. So plaintext is just a simple file with either ASCII or Unicode. Now, what does it mean? It means that plaintext files, they are not encoded in any binary format. They're not encoded in any special way. They are just raw ASCII and Unicode bytes. Now, here I've mentioned a few extensions which use the plaintext methodology, which just encode the ASCII or Unicode bytes. And here we're talking about, for example, let me open the thing. Here we have TXT, we have CSV, we have log files, Markdown, JSON, XML, HTML, org, which is probably the most, the format I use the most, org mod file, org files, because I use Emacs, and Emacs is able to process org mod files. By the way, this file that you're seeing right now, it is called readme.org, so it is an org file, and it is a plaintext file. So basically, that's the idea. Plaintext files are like TXT, CSV, log, HTML, for example, XML, for example, JSON, for example. Now, what about non-plaintext files? Now, non-plaintext files instead are for binary formats. And here we have the ELF format, which is the format used to represent an executable in the context of Linux. We have the PNG format used to represent images, the docs format for Microsoft Word documents, PDF, MP3, MP4. Now, let me be clear. I have nothing against binary formats. They are extremely useful. I mean, we need to execute binaries. We need to have complex binary formats to represent binaries, to represent programs, to then be executed by the operating system. We need to represent images. We need formats for that as well. I have nothing against binary formats. The thing I realize, however, is that sometimes binary formats are just like we just need to use them. There's no way out. Like we are forced to use them, like in the context of an image, of a binary, and stuff like that. However, when it comes to textual information, let's say we just have normal human text and that's it. I find that plain text files are much more powerful. And for example, I really don't like the Microsoft Word format, but even the OpenOffice alternatives, right? I just don't like that kind of style, that rich document format style. I'd rather have plain text. I'd rather have poor, let's say, files than rich. Now, why is that? Why do I prefer poor rather than rich? In the context of course, simple files. So I'm gonna bring you some of my reasons why I prefer plaintext, why I believe plaintext have a lot of advantages, let's say. So, and of course, now here I'm gonna mention the advantages, but there are certain situations in which we simply cannot choose. And sadly, sometimes, for example, at work, the company is like, look, you have to use this format and that's it, you have no choice. In that case, we cannot do much. Maybe that format is even ugly, maybe that format doesn't really work, it's not really readable and whatever. In that case, we just have to suck it up and use the format that was forced to us. Anyways, if we instead can choose what kind of format, if we are working on our own thing, for example, why do I suggest you to use a plain text format? So let's see some of the reasons behind this power. So first reason, it is direct and it is human readable. So anyone can open and read a plain text file with any tool. So here the distinction is the tool, because anyone can open Word and can read a Word document with Word, right? But you need Word. You have that constraint. You can only open that file with certain software. Maybe also with OpenOffice, with the open source alternatives, whatever, but you still have a limited amount of software that can read those bytes. With plain text, you need any general text editor. You can even use Add. And if you don't know what Add is, you should look it up. It's a really historical editor. It's really cool editor, but of course historical. You cannot really use it right now. It's just way too slow to use Add basically. But potentially you can also use Add to read a plain text file, because we're talking about any text editor that can read and display ASCII bytes, Unicode bytes, is able to read a plain text file. There is no proprietary software that requires special licenses also, because text editor, there are a lot of open source text editors. I mean, you can even write your own in like a few hours, so it's really not a big deal, and everything can be read and modified directly. So I would say this is one of the most powerful reasons why. It's not strictly related to proprietary versus open source, let me be clear. There is also that aspect, yes, but it is more related to you are not bound to a particular software. Now, software has a life. Software is like a human being. It's just more complex, because software has a life, and this life is dictated by many different factors. For example, if the project fails, if no one uses the software, if no one maintains the software is going to die eventually. Not like a human being. I mean, the code, if it's not lost, it can still be recovered, it can still be maintained again, of course. But let's say that you lose the source code of the program that was able to read those bytes. Then you need to reverse engineering, you need to do a lot of effort just to read back the content. With plain text file, you literally remove any sort of problem in this direction. And this is extremely powerful when you think about long time spans. If you think about 1 month, 1 year, 5 years, 10 years, we are talking about a somewhat short lifespan, short to medium. And in this kind of periods, like most software has a life that is longer than those periods. I mean, 10 years is already a lot, to be honest, but like 1 to 2 years, if there is some hype at the beginning, you typically have, right? Now, as time goes on, however, it becomes more and more likely that the software will die, become unmaintained, and maybe you lose the data, because you are tying your data with your software. Now, let's take the case for org mode. So this is an org file, and I'm using Emacs to read it, right? Now, let's say that Emacs tomorrow fails and it is deprecated and we cannot find it anymore. What do I do with this file? Well, I can open, for example, any tool. I can even open V. Yeah, actually, I don't have it installed, but I do have Vim. I can even open Vim and I can just read the same content. So a file that was designed specifically for Emacs is just a simple plain text file. I can read it also with Vim. And that's the power of plain text. Of course, I wouldn't want to do that because I use Emacs, right? But that's the idea. I mean, I can do that. Now, the thing that Emacs helps me with this thing is that it adds functionality. It makes it dynamic, but this dynamicism does not have to change the bytes of the file itself. So that's really important. Like, I would say pick a software that has always the option to output something in plain text, because that is going to make you less bound to that piece of software. The data is less bound to any specific piece of software, therefore the data can live more, and this is a power in the long term. That's my opinion. So basically that's the second point, which I mentioned so far. So since no proprietary software is required to read plain text file, it means that the files are not tied to any specific software, And this in turn means that the data will outlive any specific software. Let's repeat this again. This in turn means that the data will outlive any specific software. Like this, regardless of which software dies, the data will still survive. Now, it's not like if you use a proprietary software or a custom software and then the software is lost, you are necessarily losing the data. You can also reverse engineering the data, try to figure out the format used and stuff like that. It just becomes much harder. You have to put a lot of effort to recover the data. If your data is in plain text, you literally don't have this problem. Like the only reason you wouldn't be able to read your software is either all technology was wiped out, because basically, if we don't have the technology for reading simple ASCII and Unicode bytes, we are pretty much fucked as humanity, something happened very wrong, or you lost the data through corruption. But if you have plain text, we can also version control it much better, but we'll come to that a bit later. So, it is human readable, it is direct, and it survives much longer. So let's continue with our discussion. So far we have it is direct, it is human readable, it survives longer. Another point is layer complexity. What do I mean with this? In one of my previous videos, I talk about suckless and the need for simplicity in software. The fact that complexity can really hurt a project in the long term, complexity is a problem. However, it also has to be said that complexity sometimes is necessary. It is useful to have a complex software that does a lot of things. So in a way, complexity hurts, but it also gives back something, right? So sometimes we just have complexity. It is a cost, it is something we pay for, but it is something that we must pay for because we need it, right? So what's the idea here? Well, the idea is that since sometimes complexity is needed, we want to approach software design in a way in which we layer complexity. And to bring a concrete example, let's consider Emacs and org mode, right? So what do we have here? We have Emacs, which is a software, right? Then we have org mode. Now, org mode is not one thing actually. Org mode is two different things. It is a plaintext format, so plaintext format, and it is a Emacs mode. Emacs mode. It means that org mode is actually data and code. It is a plaintext format. It means that it defines a specific markup language with this asterisk, with this like special headers at the beginning, with list, with links, images, and stuff like that, right? It defines a language to describe stuff you would typically see in a README file, in a documentation, in an essay, stuff like that, right? So that's plain text. Then on top of that, there is a mode, there is some Emacs Lisp code running within Emacs that allows us to read this format and dynamically process it. What does it mean? For example, I can move this outline, I can close it, I can open. For example, it means I can put some code here, some C code. I can say, look, include stdio.c, printf, hello world, with the new line, and I say results output, and then I can execute this thing, and I get the output. Here, if I say, for example, print %d 1 + 1, I'm gonna get 2. So this is actually C code being compiled and executed by the Emacs org mode, by the mode that is running within Emacs. So notice what we did. We have layer complexity because we have a basic underlying format, a simple ASCII Unicode based format with simple bytes. Here, if I look at this org file within the disk here, if I do an example of this, they are just simple ASCII bytes. They are just ASCII actually, because I don't even have much. I mean, I'm not sure the format in which I use. So this is UTF-8. This is UTF-8 encoding, but it's still a simple encoding, right? A simple Unicode encoding. And then on top of that, we layer functionality, and we have more complexity. So in total, the whole Emacs plus the plaintext org is complex. However, the file itself, the data itself, is not complex, right? It's just a simple plaintext file. And this, I believe, is a good approach to software design. So plaintext starts simple, yet they can also be used to build complexity on top when it is actually required. So let's consider Emacs. Org mode is a plaintext file format, yet if you open an org file with Emacs, you also get a lot of dynamic behavior due to the Emacs Lisp code written within Emacs. And this combination, the combination between plaintext file and dynamic code execution, shows how plaintext file, they sort of like incentivize layer complexity. The fact that one can say, yes, but plaintexts are so boring, man, I cannot do stuff with it. It's not true. It's not true, and org mode is a perfect example of this. We start plaintext, we build on top, the underlying data remains simple. So this is like a really big important thing, I would say. The last reason that I have is, I mean, there are more reasons, but these are the most important ones. These are the ones I want to focus on. So the last reason is version control friendly. Plaintext files can be easily managed by version control software such as Git. And I've made a video on Git. Git is a really powerful tool when you need to organize your files, when you need to see changes between different versions, right? And you want to go into the single diff, right? Into the single bytes that change. A plaintext file is essential. And of course, all source codes, after all, are plaintext files. So to finish off the video, let me bring you some practical example over how I utilize the power of plaintext, hoping that it might like bring you some kind of awareness, like, okay, I can actually use plaintext for doing these kind of things. And of course, let me be clear, many of these examples use org mode and Emacs, because that's mainly what I use. So right now I'm working as a cybersecurity trainer, and which means that I teach a lot. Now, when I prepare a lecture, I always start with an org file. For example, here I have 2 files for 2 videos, the video on the syscall, on adding the syscall. And for example, this kind of content, which is you have to do a lot of steps, you have to be very careful over what you modify. I would say I really like the way it comes off with org mode. To me, it's clear what I need to modify. I can just see directly, I can put links, I can put code, the code is highlighted, like it's just really, really smooth. I enjoy it. So it's really useful. Like when I want to teach something, I always start with an org mode file because it grounds me. It makes me understand, okay, what is it, the idea that I want to convey in this lecture, in this video. And I think that one of the, like if you appreciate my lecture, thank you very much. And I believe that one of the things that helps me is to be grounded on the ideas. And I'm grounded on the ideas because I start with an plaintext org file, basically. So that was for the Linux adding. Another example is the roasting attack. Here you can put, any block, example block. Here you can put some commands, some output. It's really, really flexible. And I really love it, basically. I mean, there's not much to say. This video, by the way, are public, so anyone can see them. You can just check them out. So for teaching, I always use org mode. I also use org mode to write apps. So let's say I'm doing a CTF or a boot to root machine in one of those platforms, right? Like ActeboX. I have a couple of videos on ActeboX, and I noticed that throughout my years, I've pretty much came up with better ways to write reports, but always using org mode. So for example, here I have a summary, here I have the scope, here I have the high-level overview, here I have the tools. For example, my OSCP report was written in an org mode file. So that's the idea. The foothold, I have the foothold. Actually, maybe it was written in a markdown file, but it's still plaintext file. And then later I also extended it to org mode. I don't remember, I don't remember which, but basically what I did was first write in an org mode all the POCs, all the screenshot, all the data, and then I wrote them in a markdown. After the exam, I actually extended the setup I was using so that I could do everything within a single org mode file. But that's just a little note. Anyways, when I was doing the OCP exam, I had an org mode file on my side and I wrote everything there, divided by machine, the Active Directory session, the three independent machines. Like, it's extremely useful to keep track of things, to never forget things. And if you use it if you use it with care, it really gives you a lot. Like, for example, I really like this thing. Like, I have the command, I have the output, I have the other command, I have the output. Here I can highlight stuff where it is important. It's just extremely, extremely useful. So also for apps, I use it. Now, of course, I make videos on YouTube. I have 2 YouTube channels, English and Italian. And for my YouTube channels, I have a big org mode file. I mean, look at this. I have this org mode file. And here I pretty much have all the videos that I've done. They are 155, and with the various stages of preparation, if I have to prepare them, record them, if they are done. And basically for every one of them, I have a bunch of properties, I have the description, I have the timestamp, I have the references. It's just a lot of metadata cover into a single org file, and this is extremely useful. And by the way, I use this data and I parse this data dynamically with Emacs to extract myself all the useful things and to generate the directory that is available under Patreon, which is the exam video notes, this one, with all the details over the various videos, basically. So that's the idea. So let's continue. So YouTube, I also use org mod for YouTube. Now, anytime I have notes of different kinds. And to take notes, I use a package called dnote. And dnote is developed by Protesilaus, which is a very important contributor in the Emacs world. I suggest to go check out his work. He also has a YouTube channel where he talks about philosophy. It is an extremely interesting listen if you never listened to him. So I really suggest you to check out his packet, dnote. Dnote is used to take notes and link notes together, so very, very powerful. And in general, Protesilaus is a key character in the Emacs world, so go check him out. Now, other contexts which are a bit more on the edge, so they're not related to node vaulting, I'm using HLedger to do budgeting, to keep track of expenses. And the cool thing about HLedger is that it is a plain text-based accounting system. It means that the way you track your expenses is through a plain text file. And in this plain text file, you write expenses as follows. Like you have, okay, this is the date I went to buy the groceries, I spent, 30 euros, and I use my bank to pay for that expenses, right? You just write normal ASCII characters, and then you have a tool that processes all the entries and gives you the balances for the various accounts. It gives you if you own some money, if some money is owed to you, how much you spent on groceries, on going out, on whatever, on food, whatever. It's like it is an extremely powerful system to keep track of your expenses, and if you combine this with a version control system and a backup, you can keep this data stored for a long, long time. And it is also very efficient because it doesn't really waste any space. There's no metadata for a specific program that you have to load. There is no being tied to a specific budgeting program that could go out of commission, that could just disappear and not work anymore. You literally have all the power of your data, and this is a key thing. And one of the things that I also use it for is for the agenda. So I have all my work calls, my work meetings, my work appointments, and also my personal life appointments within an org agenda, because org mode also allows you to handle an agenda. And once again, it uses a plain text-based approach in which you have entries. Like, for example, let's say I have a work call. Let's say this work call is scheduled for the 7th, 2025, it's a Monday. Maybe here I can also put a date, like an hour. Like, I don't know, at 10:30, I have a call, I have something, and then I can process it with org mode and I create complex flows on top of it. But at the end of the day, once again, it is all based on plain text. So most of these things have to do with org mode. It's just this budgeting that uses HLedger. So this is like a very org mode based video, I would say. But at the end of the day, it is not really specifically about org mode or about Emacs. The idea that I want to discuss in this video is more general, and it is about plaintext. You can develop your own tool which processes plaintext files. And what I suggest is that when you develop a tool, try to go for plaintext when it is enough, when you just need that and you don't need anything more advanced or sophisticated. Of course, in contexts where you need extreme efficiency and you have a lot of data, plaintext typically will not suffice. You need to find efficient encoding methods, and those are typically binary formats. Now, I understand that. Once again, I'm not saying that plaintext will solve all the problems. What I'm saying that is that from a personal point of view, when you have to organize your life, your data, typically you do not generate a crazy amount of data, right? Because it is data that is based on your limits as a human. You have 24 hours, you cannot do like 10,000 tasks every minute and stuff like that. So you are limited in the throughput of data that you have related to yourself, right? So to handle those data, typically plaintext suffice. And I suggest you just stick with plaintext so that in the long term, you always keep access to your data. You never lose it because a weird program stops working, because you can version control it much, much better with tools like Git, and because you can add on top of plaintext data your own computation, your own abstraction, your own complexity. So that's the idea. Let me, tell me yourself, what do you think about plaintext? If you use plaintext, how you use plaintext, let me know, I'm curious, and to the next video.